Welcome back, friends. Today we are going to solve LeetCode problem 589 N-ary tree pre-order traversal and its subsequent problem 590 N-ary tree post-order traversal. So this is similar to binary tree. This is a N-ary tree that is given to us. So in binary tree we can only have a left and right child, but in the N-ary tree we can have multiple children, right? So this is what they have given. They have created a node class, and every node will have value, and it will have list of children, right? So it is similar to binary tree, but the only difference is it will have multiple children, right? Every node can have multiple children. So let's just take a look of these examples over here. So this is one big tree that we have, and we want to do the pre-order traversal. So in the pre-order traversal we always first visit the root, right? Root, then left subtree, and then right subtree. So root, then you can say left and then right. So let's just do the pre-order traversal here. So first root, so we will visit root here 25, then left, we will go left and then we will go right. So first we are going left. Now again we will visit root, so 15, again we will go left and then we will go right. So again we go from here, we came here, now from here we are going left, so we are visiting root 10, so we are visiting 10 here. Now we have to again go left and then we will visit 4 because it does not have any children, so we will only visit 4 here, and after 4 is done we will go right here and we will visit 12 here, right? So 12. So in the, as you can see, in the pre-order traversal we always visit first the root and then left and then right. So now we are done so far, we are at this point. So now we have to go right here, right? Because right subtree is there. So in right subtree again we will first visit the root, which is 22. So 22 here, then we will go left, so we will visit 18 here, 18 is there, and we will go right, so we will visit 24. So 24 is there. So this is the traversal that I have shown you for this left subtree, right? This is the left subtree of 25. Now there is another subtree here, which is a right subtree for the node 25, right? So again we will go right side, we will visit 50 first. So 50, then as you can say we always go left first, then first left, then 35, then 31, then 44. So 35, 31, 44, and then we will go on the right side here. So 70 here, 66 and 90, 70, 66 and 90. So this is the pre-order traversal. So let's look at the implementation, how we will implement this. So we have to return list of integers. So I just created a array list here, and I created a recursive function here called as recursive preorder, and we are passing the root and the result, this list here, right, to the recursive function. So recursive function is just returning void. So base condition for this function is if root is null, right? If the node that we are passing is null, then we will simply return. We don't have to do anything in that case. Otherwise, as I said, in the pre-order traversal we always visit the root first. So we will just add the root's value into the result. We will get the children of this root, and then we will recursively call our function for their children, right? Passing the children here, like every child here and list here, basically, right? So that's how it works here. So here there is no left and right concept because this is a n-ary tree, so we will have to do recursion for the all the children here for that node. So as you can see, this is the n-ary tree. So first it will do 1, so 1 you can see here, then it will get all the children 3 to 4, then it will call the recursive call will call 3, so it will put 3, then it will try to call its children first, right? Then 5 and 6, as you can see 5 and 6 here, and then it will go and do the for these children, right? 2 and 4, so 2 and 4. So this is the pre-order traversal. So I created both these test cases that are given to us here, and let's just quickly run this code and make sure it's working fine. So it's giving us correct result. So as you can see, we are getting the correct result here. So we will just submit this. So our code is running 100% faster, 0 ms. So this is pretty good. So this is just like implemented a pre-order traversal using recursion, right? So we just first print the root, and then we just call recursively function for its children. So we will be doing the same similar thing for the post order traversal. The only difference in post order traversal is that first we actually visit the children, right? We will first visit the children like left and right in case of binary tree, and in case of binary tree we will visit all the children first and then we visit the root, right? Let me just take this back, and I'll just show you quickly for a binary tree, and then we same thing we can just do it for the n-ary tree. So this is the post order traversal, right? So first let's say we are here at 25, so we will not I mean we will visit but we will not print it, right? Because we will first want to go left and right both, so we'll go left and right. So here again for this node we will go left and right. So as you can say, again we reach here, we will go left and right. So when we reach the end, then first we will put 4 and 12 here, right? Because first we want to always put the left and right, and then we want to put the root. Then we want to put the root. So we put the root 10 here, right? Now we came back here with 15. So we are done with this small tree, right? We are done here. Now we are at 15, so we will go 22, and we will go here 18 and 24 we will go, right? So we put 18 and 24 because always first we have to go to the left and right, and then we will put the root. So then we put 22, right? And then we went back and we put 15 at the end, which means that we first did left tree, then we did the right tree, and then we are doing the root basically. So this is called as post order traversal, right? First left, right, and then the root basically. So post order traversal. So the implementation wise it is similar to our pre-order traversal. I created a recursive post order function, and I'm passing a root and the result list here. If root is null we are going to return, otherwise we will get the children, right? Now we will call the recursive function for the children, basically passing each child here, and after we are done with the children we will pass the root value there, right? That's what we are doing here. We after we are done with all the children, then we are adding the root value, correct? So that's what we are doing here also. So this is the only difference. So first we will call the recursive call for all the children, and at the end we add the roots value to the list. So here I have one example I took. Now let's take this another example also. This is a little bigger tree, and we'll just run the post order traversal. So as you can see we are getting the correct result here, and we'll just submit this. So our code got accepted. It's 100% fast, so it's pretty good. So this is the way you can do a recursive implementation for a post order traversal for n-ary tree. You just have to do first you will call the recursively for all the children first, and at the end you will add the roots value, right? Because it's a post order traversal. So as you might know, I often create LeetCode solution videos using Java J2E, as well as interview related helpful videos for Java J2E technologies, and I have a couple of playlists already created there for LeetCode solutions, as well as computer science programming things like BSF, DFS, dynamic programming, arrays, linked list. So please check it out. It's has a lot of good stuff. Please subscribe to the channel. Subscription will really help my channel to grow and reach to more people. So thanks for watching the video.